Hi everyone, welcome again. In this video, we will learn Spring Cloud Config Server. Let's understand what it is and where does it fit in the microservices architecture. Consider we have a microservice and this microservice needs some configuration, some properties. To manage that, we have created an application.properties or application.yaml file in the code base, and we are keeping all the required configs and properties in this file. And an application moves from one environment to another environment, from local to dev to TSD to production. So the value of a particular property may change depending on the environment. For the same property may have different values in dev and in TSD. To manage this, we often use profiles. We create profile specific properties and we use or activate the profiles depending on the environment. That's well and good. So we have this microservice, we created the jar and we deployed this application in an environment. Now suppose we need a new property. So we will add this property in the properties file, then we will make the required changes in the code base in order to use that property. And because it's a new change, so we will commit the code, trigger the pipeline, create a new jar or new binary, and that new jar will be deployed in a particular environment. Now suppose we have to modify an existing property, so we change the value from A to B for a particular property. If we do this change, if we make this change, that change will not reflect in the service which is running in an environment. To do that, we have to commit the code again, trigger the pipeline, create a new jar, and we have to release that version and we have to reboot the server. And we have to reboot the server even though there is no change in the logic in the actual code. We just change the value of a property. That is not a problem for a simple application which is running on a single instance. Now consider the same use case in the setting of a microservice architecture where a microservice is running n number of instances. So instead of one instance, we now have n number of instances of the same service. And if we modify a property, we have to now reboot all the instances, which may impact the cluster, because if we reboot all the instances, it will take some time for the cluster to get all the servers up and running. And we have to do this even though there is no change in the code. We just modified the property. Now the question is, can an application read the updated value without a bounce? There are available solutions. People generally use @refresh scope annotation with the actuator. So in order to refresh the property without the bounce, we need to hit a particular endpoint which is exposed via actuator. That will refresh the context, that will refresh the properties of a running instance. But if there are n instances, we will have to do the same thing with n instances. And even though we have extracted and put all the configuration and all the properties in a single properties or YAML file, the configurations are still attached to the code base. So if we make a change in the configuration file, we still need to release the whole code base. So we need to think about something in order to scale the services and to minimize the downtime. Can we externalize all the configurations from the code base? So that means, can we extract all the configurations so that it is separate from the actual code base? And the second thing is, how can we refresh the properties? How can we propagate the changes in the properties without the server bounce? And that's where Spring Cloud Config comes into the picture. So Spring Cloud Config Server is a separate service that is specific to the properties. The responsibility of this config server is to manage the configurations of different microservices. It can handle the properties of different services. It can handle different profiles of the same services. Its job is to manage the configurations. So when we use the config server, we extract all the configurations from the code base and we put this configuration data in the Spring Cloud Config Server. And when there is a change in one of the configuration or in one of the properties, this config server will notice that a property has changed and it will propagate that change to all the required services automatically. And so we don't need to restart the services. If there is a change in one of the properties, the microservice will get an update notification from the config server and that property will be refreshed without any server bounce. And the second benefit is, if we are making a change or if we are changing the properties, we don't need to release the code base because now properties are separate from the microservice code base. In a nutshell, we are extracting all the properties from API code bases and putting them at a central place, which is the config server. So config server becomes a centralized place for all the externalized configurations and properties. Now the next question is, where does this config server put all these properties and configurations? Well, the config server doesn't store all the configurations itself, but it supports different ways to store this data. Let's explore those options. So the first one is a Git repository. We can have a dedicated repository to store all the properties of different microservices. When we have a repository, we get all the benefits of a Git repository, including the version history. For instance, if anyone is making any change in one of the properties, and because this is a repository, so we need to follow the process that includes committing the code, raising the PR, merging it, and it creates the version history of that change. So that change can be tracked. And this repository can be a remote repository, a private repository, or a local system repository. Config server can use a vault, a secure vault, to store these configurations. And it can also work with discovery clients in case of a service discovery, let's say Netflix Eureka. Now that we understand the basics of a config server, in the next video, we will develop our own config server. That's it for now. See you in the next video. Thanks for watching.